First law of thermodynamics. As the temperature of a substance rises, the particles will move faster and will also get closer to each other during collisions. In a solid, the particles will vibrate. In a liquid or gas, they will move around. The internal energy, made up of the kinetic and potential energy of the particles, has increased. Kinetic energy due to their motion, and potential energy as they move closer to and further away from their neighbours. The further away they are from their equilibrium position, the more potential energy they will have. This increase in internal energy can be produced by heating or by working. Heating requires contact with an object at a higher temperature. Working requires motion, which can include the motion of an electric current. The law of conservation of energy tells us that the rise in internal energy must be equal to the energy gained by heating plus the energy gained by working. We can write this as delta U is equal to Q plus W, where delta U is the change in internal energy, Q is equal to the heat energy gained by the substance, and W is equal to the work done on the substance. Heat energy lost by the substance, or work done by the substance, would appear as a negative value. For the gases inside the combustion chamber of a rocket, the heat energy gained by combustion will be equal to the work done by the gases as they expand out of the nozzle. This is taken as negative work done on the gases. The internal energy will remain constant. So, if the energy gained by heating per second is 20 megajoules, and the work done by the gases per second is 20 megajoules, we get delta U is equal to Q plus W, the first law of thermodynamics, and delta U will be 0 joules. The internal energy overall does not change. There is a gain in heating of 20 megajoules and a loss through work of 20 megajoules, which appears as minus 20 megajoules. As solids and liquids are generally virtually incompressible, W is usually negligible, and this gives Q is equal to delta U, which means the energy given to the system through heating becomes the change in internal energy of the system.